to understand fractional ratios and rates. Now, ratios and rates are very similar. The big difference is that ratios are the same units and rates are different units. That's the difference, basically. Okay? So, as I mentioned, when we have a ratio, I might say 2 to 3. I'm comparing 2 cups of sugar to 3 cups of flour, but they're both cups. Same unit, so that would be a ratio. Where a rate would be, I am driving 55 miles per 1 hour. Different, right? That's the difference between a rate and a ratio, but we're still comparing 2 quantities. So, if we're thinking about fractional ratios, well, first, 15 to 5 is the same as 3 to 1 because both of these are divisible by 5, right? So I could write this as just 3 to 1, no problem. 15 to 20 is the same as 3 to 4, or we could write that as 3/4. Well, this gets us into the idea of unit rate. And a unit rate, or a unit ratio, right, compares to 1. So if I have 3 over 1, that is a unit rate, because unit implies this is per 1. Well, what happens when I have a ratio of 3 to 4, but I want this to be a unit rate? Well, we can write this as 3/4 to 1. And now we have a fractional ratio, okay? So, keep in mind that the unit rate or the unit ratio is per 1, right? So we want this to be some number compared to 1, or some number over 1, or some number to 1. Either way, however you want to write that ratio, we're comparing to 1. So find the unit rate of the following ratios. Okay, so we have 24 to 30. So first things first, I reduce best when I'm looking at it as a fraction. That's just a personal thing. And I see that 24 and 30 are both divisible by 6. So 24 divided by 6 is 4, and 30 divided by 6 is 5. So this is a reduced rate, right? Or we've simplified the ratio. If I want to make it a unit rate, I'm just going to make it compared to 1. So 4/5 to 1. Okay, let's look at the second one. I have 4/5 to 8/9. This is a ratio. We want to make it unit. So we want to make it some number compared to 1. Well, okay, let's think this through. This is the same as 4/5 over 8/9. This is a fraction divided by a fraction. Well, how do we divide fractions? Well, if we're dividing 4/5 divided by 8/9, maybe you remember that the first fraction stays the same, division becomes multiplication, and we flip the second fraction, right? We multiply by the reciprocal. Now, when I do that, I can reduce numerator to denominator. 4 and 8 share a common factor of 4. And so when I multiply straight across, then I get 1 times 9 is 9, 5 times 2 is 10. So 4/5 to 8/9 simplifies to the ratio of 9/10. To make that a unit rate, we simply make it to 1. So 9/10 to 1, and we have ourselves a unit rate. Let's do one more in application way. If I walk half a mile in 1/5 of an hour, what is my speed in miles per hour? Whew! Okay, so first thing, I did a little trickery here. Half of a mile. Okay, so that's 1/2 of a mile in 1/5 of an hour. So think about this. I have 1/2 to 1/5, right? We're talking miles to hours. Well, it's just like what we just did. 1/2 divided by 1/5. So if I think of that as a division problem and then change that, right? Division to multiplication, multiply by the reciprocal, so we flip that second fraction. Nothing reduces numerator to denominator across those, so we multiply straight across. 1 times 5 is 5, 2 times 1 is 2, so 5 halves. If I make that a decimal, 5 divided by 2 is 2.5. So 2.5 miles to 1 hour. And now we've made it a unit rate. Okay, so that's dealing with fractional ratios and how we can make it. If you tell someone I can walk half a mile in a fifth of an hour, they're going to go, I don't know what that means. But if you can say I'm walking 2.5 miles per hour, now we can understand that, right? I walk on my treadmill. I know what 2.5 miles per hour looks like in terms of my speed. So sometimes dealing with fractional ratios, we need to turn it into that unit rate so that we can understand what we're talking about, because that is oftentimes the mentality that we think in. And that's why these are important.